In this video, we're going to be going over how to solve a system of equations using elimination. First, you're going to want to get matching opposites, and we'll talk about what that means in our example. Then add to eliminate one of the variables, and then solve for the remaining variable. And then plug in the variable you found to find the other variable. So let's do an example. So here we're going to solve the system of linear equations using elimination. Our equations are 2x plus y equals 4 and 2x minus y equals negative 1. So we want to get matching opposites. So matching opposite would be like if I had a 3x and a negative 3x, because they're matching, but they're opposites. And when I add them together, it gets me a 0. So that's what I'm looking for. So here I see that I have matches, but they're not opposites. And here I see that I have matches and they're opposites. So that's going to be our matching opposites are our y. So in this particular instance, we don't have to multiply anything to get our matching opposites because we already have them right there. So we're going to go ahead and we're going to add now to eliminate one of the variables. So we're going to eliminate that matching opposite. And that's going to leave us with a 4x equals 3. Then from here, we're going to finish solving. So I'm going to divide 4 for both sides. And that's going to give me the x equals 3 over 4. So that's one of my two answers. So one of my answers is 3 over 4. And now we just need the other answer. So I want to take that. So we're going to do our third thing, plug in the variable that you found in for the other variable. So I'm going to plug it into my top equation. It really doesn't matter which one you plug it into, but the top one looks easier because it has the plus sign and it's got a positive 4. So I'm going to take that 2x plus y equals 4, and I'm going to take out that x. All right, I'm going to take the x out. I'm going to plug in my 3 over 4. And I'm going to solve for y. So this is going to give me a 6 over 4 plus y equals 4. Then I'm going to subtract 6 over 4 to both sides. And really here, I'm going to use my calculator because my calculator is going to make it so that I don't have to worry about like denominators. And so I'm going to have 4 minus, and I'll pull up my fraction, 6 over 4, and I'm going to hit enter, and I get 5 halves. So 5 halves, and that is going to be my solution to my system. Let's do another one. So here we have 2x plus 2y equals 7, and 2x plus 5 equals 1. So notice that in this case, my x's don't match, and my y's also don't match. I'm going to have to do something here. So in order for that to happen, I have to decide, do I want my x's to go away or do I want my y's to go away? And I'm going to choose the x's just because they're first. In this case, it doesn't really matter. It'll be just as easy to do the x's or the y's. So I want to know what will make 3 and 2 matching. So what number can 3 and 2 both become? Well, they can both become the number 6. And I can get that by multiplying my bottom, everything on the bottom, by 3. And by multiplying everything on the top by 2. Now, right now, if I look at my 3 and my 2 here, they're both positive, which is great, except that I want it to be opposites, right? One positive, one negative. So I need to decide to either make my 2 or my 3 here a negative. And I'm going to choose to make my 3 the negative, just because it's on the outside, or on the bottom, rather. And so I'm going to distribute this 2 to all 3 spots. And so that's going to get me 6x plus 4y equals 14. And then I'm going to distribute this negative 3 to all 3 pieces. And that's going to get me a negative 6x, a negative 15y, and a negative 3. Then I'm going to add these together. And my x's are going to cancel out because remember, those were matching opposites. They were both 6x's, and one was positive and one was negative. Then I'm going to have a negative 11y equals a positive 11. So to finish, I'm going to divide both sides by negative 11. and that's going to get me that y equals -1. So I have part of my solution. So I'm going to plug that -1 back in. When I plug it in, I need to plug it into either the original first equation or into the original second equation. It doesn't matter. Either one will give me the answer, the correct answer. So I'm going to plug it into the bottom equation just because it looks like, why not? So I'm going to plug it into 2x plus 5y equals 1. So I'm going to replace my y with the number -1. So now I have 2x minus 5 equals 1. Then I'm going to add 5 to both sides because I'm having to solve for x. So 2x equals 6. Then I'm going to divide both sides by 2. And that's going to leave me with x equals 3. And that is going to be the solution to my system, 3, -1. And so that's how you can solve a system of equations by using elimination.